Okay, fine. Perfect. Let's start. Thanks for joining. And I hope to give you some fun now with this session. Well, that's actually fine, fun, because it was unexpected, but tomorrow I had the previous session, so I showed this slide, and then my phone started. So it was quite embarrassing. I didn't expect a call from Italy, because right now, or in the morning, was around midnight. So okay, but please silence your phone. Explore everything that PAS has to offer. And please remember to fill in the session evaluation. Few words about me. My name is Andrea, and Martorana Tusa is the family name, the last name. I am from Italy, and I'm working in this company called Würth Phoenix. We are the IT company for the Würth Group, basically selling industrial tools, drills, hammers, screws, all this kind of screwer, all this kind of stuff at a professional level. I'm in the IT company. We are doing BI for many years. And I'm a speaker in many events, of course, usually in Europe, SQL Saturdays, Power Platform World Tour, whatever is related to BI, and I'm doing a lot of speeches during the all year round. Then, again, I have a disclaimer. As an Italian speaker, probably you can find my accent quite weird, exotic, so please, if you don't understand, seriously, stop me, ask me to repeat, and take into account that I'm jet-lagged, of course. And body language is part of my speech. It has Italian, so some gestures are included into the dialogues. And I really focus on it because the correct pronunciation is report, but it's not natural for us. We say report, not report, so please, I beg your pardon for this. And maybe I can randomly miss some S at the end, or add the non-expected S at the end of my words. And then let's go to the topic for this session. Well, the topic is try to apply what are special features from SQL Server, from Power BI, and from R. Probably you know that from SQL Server 28, actually, the spatial data is supported. And maybe you have attended some sessions explaining the methods, the type of spatial data. But what I found that is totally missing, it's a concrete, a real application for this kind of data. And this is my goal today. So showing you how you can really apply this data to a case study. We will talk about SQL Server support for spatial data, for Power BI mapping features, and then R. Let me introduce spatial analysis. This definition is coming from Esri. This is the leading authority. It's a private enterprise, but this is the leading authority for spatial analysis, and it's releasing a tool called ArcGIS. We will talk about it later on. So spatial analysis. Think about how we understand our world, mappings, where things are, how things are related, spatially, what it means, and what action to take based on our perception. 6 categories for spatial analysis: understanding where, measuring size, shape, distribution, determining how places are related, finding the best locations and paths, detecting and quantifying patterns. And this is coming from a book edited by Esri. And making predictions. This is usually achieved by the use of a GIS tool. Okay, GIS, Geographic Information System. It's a system designed to capture, store, manipulate, analyze, manage, and present spatial or geographic data. So all the activities related to spatial analysis are usually performed via a GIS, a software called GIS. Collect data, compare data, calculate overlapping, calculate distances, doing prediction. All this kind of stuff is usually handled by a GIS. Most common GIS systems are ArcGIS, commercial tool from Esri, and QGIS, open source. If I need to edit some files, I'm doing it usually with QGIS. I have a release of GIS, and if I need to edit this is what I actually did for this session. If I need to edit files, I'm doing it with QGIS. But is there any chance to perform some kind of spatial analysis not going on either a commercial or open source tool? I mean, you must be a specialist for using that kind of tool. It requires skills focused on spatial data, spatial analysis. So my question was, is there any way for using our common tools in the everyday work for performing some kind of spatial analysis? I'm trying to answer yes in this session. How can we use? We can use the spatial data support in SQL Server. It's native, it's there. Why don't use it? We can use mapping visual. Power BI is very strong in mapping. You have some built-in visuals, but you also have some visuals coming from the marketplace developed by the community. So there are many, many visuals that can help you in displaying data and doing some kind of analysis using Power BI mapping features. And R. I will talk about it later on, but R, it's powerful, very, very, very powerful. So the idea was, OK, how to cook all of the ingredients together and try to perform a spatial investigation based on a fake case study. That it's actually something that companies need to perform quite often. So the idea is, OK, I have to locate a new store. And I was thinking about a multinational group that designs and sells ready-to-assemble furniture and home accessories. It means, yeah. And let's have a deal, please. I call it IKEA. OK? So please, let me call it IKEA. I found it in every country, there's a different way to pronounce it. So for me, it's IKEA. Let's make this deal. Yes, so they want to open a new store in Denmark. Why Denmark? Because actually, it was a good area for performing this kind of analysis because it's a small country, few stores, and the distribution of the stores was good for trying to figure out if there is any free available area. So it was because there's no a big amount of data, because if I took a larger country, that would be complex. Okay, so we, as IKEA, we want to open a new store in Denmark. Okay, what kind of questions? If you ask to open a new store, what are the questions that are coming into your mind? Yes?
Population density.
Population, of course. Distribution, I would say, of population.
Yeah.
Distribution of population, of course. Then?
How big a store, how much space you need ground-wise.
Okay. Other
Proximity to other stores.
distribution of other stores of the same brand. Sorry? Absolutely, yes. Yes.
What's the cost to open a store per square foot?
Okay, I didn't I didn't have this kind of complex analysis. Yes, I think more or less we have all the same feeling. So where are these are some questions, but of course you can add some questions, further questions. You can agree or disagree, but just a list. So where are the other stores from my brand? So is there any uncovered area by this low current distribution? Potential customers. It means population distribution, but not only population distribution, but also, for instance, age. For instance, what is my target? My target is families. My target is, I don't know, single people. The age range. I'm targeting families from 30 to 50. I don't know. So just to size the research, my customer target profile, distribution across the country, income, of course. And the other question was, do I have any other store of the same market segment from furniture nearby? And is the new area easily accessible? Because this one allows me to show how powerful R is in this kind of activities. Okay. So, according to the previous assumptions, we defined a target area based on some parameters, because, and this is exactly how the GIS system works, I have to define some parameters, and then I have to make, to give these parameters a rating, and then I pile up all the ratings from the different parameters, and the higher, of course, wins. Okay, so this is that was the approach. For each parameter, I'm giving a rating, but I cannot dig into the details. I have no time. But this is how it worked. For every parameter, these are my parameters. For every parameter, I assigned a rating based on some assumptions. Distance, if the town is far from the existing store, I assign a higher parameter, in this case, the distribution of population and all this stuff, income. So for every parameter, there's a rating. Okay, and the scoring system is in the appendix. The slides are updated, so if you are curious, you can download. And then let's start. First point, location of current stores. I started from the addresses, and then I geocoded the address. Okay, so it means that using Google APIs, I translated the address into latitude and longitude. First advice, use punctual coordinates. Don't rely on names, addresses if you can, but try to transform everything into coordinates. So I performed geocoding using Google APIs. How? Let's see. And this is the first demo. So I have this, and I did it in 2 ways. In Power BI, I just imported this data. This is the real current location for the stores in IKEA stores in Denmark. There are 5 stores currently. So this is the current location for the IKEA stores in Denmark. I have this column merging together all the data for having the full address. And what I want to do is translate this full address into coordinates, making a geocoding call. How to achieve it? By using, not this one, edit queries, by writing a custom function in Power BI for performing geocoding. This is an M custom function, and I'm calling the Google API here, Geocoding API, in this custom function. So from Power BI, I'm declaring a custom function, and then as a parameter, I'm passing this full address. This is my parameter. And I'm calling the Google Maps APIs for geocoding. By the way, it means that you need to have a Google account, because right now, unfortunately, it's not longer free. So you have not to pay, because actually I'm not paying, because it's there is a range that is of calls that is free. But you need to register for having, if you are calling Google APIs. Then what I'm doing, this is my data set. I'm applying the function to the data set. So if I go, I'm adding a column, invoke custom function. And then let's call it geocode. Function query is my geocoding API. Apply the function to the shop full address. Okay? Invoke a custom function. Just give a name and call the function. The parameter is the shop full address. And if I'm doing it, this is the output. I get, from this call, I get the coordinates I need. So I'm getting latitude and longitude for every shop. Okay? Just invoking this function. It works fine. And this is the first way for showing you how to apply some spatial capabilities into these kind of tools. But don't use it if you have a large amount of data, because one, it's quite slow. It works fine for 5 rows, but it's quite slow if you have, I don't know, 1,000 rows. It's slow. And anytime you open Power BI, it's calling again and again and again the same function. It means that the data is not changing, but you are adding calls, and you are running the risk to be billed for it. Okay? So don't use it. If you just need a few rows to be geocoded, you can easily do it. Don't worry. But if you start with some a large amount of data, actually, this is what I'm doing. I'm doing it via trivial SSIS. So reading the data. The data is coming from an Excel sheet. I have this is the list of all the municipalities from Denmark. So another way of doing it is just doing via SSIS here. You have a C# script that is calling the API, the Google APIs, and you can simply, if it's open, come on. OK, Visual Studio is not. There's a C# script behind that is calling and you can find many. OK. Oh, fine. And I have this geocoding somewhere. OK. This is calling the API. And what you need, as I mentioned, is a key. You got to register in Google, and then you need your own key for performing this kind of calls. And then the output, it's redirected into a SQL Server table. So I'm doing it every time I need. Just running the SSIS, writing into this table, and then pulling the data into Power BI from SQL Server. So this is what I get here. This is my final table, and I got these two. Actually, I got these two columns, latitude and longitude, from the bypassing the name of the town and the area. OK, it's not listed yet, but the area, the region. And I got the latitude and longitude. And I also transform this data into a geography data type in SQL Server. This is a geography data type in SQL Server. OK. So first step, geocoding. How to achieve geocoding, either via custom function in Power BI, works fine. Anyway, you need to use an API. Is it Google? Is it OpenStreetMap? Is it whatever you want? You need to, if you want really to have precision in your data, you need to perform geocoding. First point, geocode your data. Sure. No, sorry. Can you speak louder?
Is that the centroid of the county? Is that the lar long because it's not a specific address?
Sure. Here I'm geocoding points because they are the name of the city. If you have an area, I wouldn't use, and this is actually what I'm doing, a different kind of map, the shape maps. And we will talk about it in a few seconds. OK? This works for single points, spots. OK. Then, yes, so let me show how to represent this data in in Power BI. Then, no, not this one. It's on the virtual machine. Come on. OK, so then I have this data I have my data in Power BI. So my data, it's geocoded, it's ready. Where are you? OK. I have my data geocoded, and I want to show this data. How can I do it? By using a standard visual. This is a standard visual from ArcGIS. There's the standard visual for ArcGIS in Power BI. Please, even though there's a Microsoft guy here, don't use Bing Maps. Don't, OK? You agree?
Oh, totally agree.
OK, fine.
I recommend my customers not to use it.
OK, even though another option is to use for geocoding the APIs. The APIs are working fine. Bing Maps, please, don't use it. So my advice is to use either ArcGIS map, or there is another powerful tool that I'm not showing you today. It's called Mapbox. It's very, 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 very nice. But let's stick on. Sorry? No, I'm sorry. I cannot hear if you speak. Map info, but it's not supported in Power BI. No, it's not supported. This is simply the. Okay. So 1 point, please. Where is it? Maybe refresh. Come on. Okay. Yes. So, where? Okay. My data is here. So, please shape your data in the way that Power BI understands that this data is geographic data type. So, if I have latitude and longitude, I can simply select my field, and then if I go to modeling, data type. Okay, I should convert. Yes, I should have converted it into decimal. So let me, and then yes. So this one for me, it's a decimal number. Okay, and the latitude as well. So some tweaking is necessary every time. Okay, close and apply. Again, go here, select latitude, modeling, and then go data type decimal number, it's fine. And then here, tell Power BI, this is a latitude field. Okay, you can see we have this option, and we are also having some options for trying to tell to Power BI that our data is kind of geographic data. Okay, latitude and longitude, and as you can see here, I have the word now, because it means that Power BI understands that this data is geographic data. Okay, then on my buckets, let's add latitude and longitude, and hopefully, yes, okay. So we have our, I hope that you can see, but let's make it readable. So I'm mapping my data, but let's make these symbols. Okay, so let's do it. Okay, and larger. Oh, amazing. So this is my map with the location of my stores. Okay, now I have Denmark. I have the location of my stores. Is there any area that is uncovered by the distribution of my stores? Yes, I can see it at a glance, but there's a nice way of doing it using ArcGIS. Who asked me before, but anyway, yes. So this is the way. If you go into Edit and go on Analytics and go on Drive Time, this is what I'm doing. Just select all my stores. I have 5 locations selected, and then how far are you driving for getting to IKEA from your home? Don't know, 50. Okay, here we are talking about miles. So let's say 30 miles. I don't know. And this is the driving distance from the point for a radius of 30 miles. But there's also another option that is the driving time. So drive time and 30 minutes. Okay. So this is the drive time of 30 minutes from every point. And unfortunately, 30 minutes is the largest amount, because if you want to have an additional drive time, you have to subscribe to ArcGIS. There's a small subscription of, I guess, $5 per month that gives you more features. But the largest distance, no, the largest time that you can have for free, it's 30 minutes. And these kind of lines are called isochrones, same covering the same driving distance in the selected area. Okay, so as you can see, if I switch back to the let's radius 30 miles, for instance, I can see that there are two areas that are uncovered by my current distribution. Yes. Okay. This one on the west coast of Denmark, this one, and there's a small area down here. And actually, I focused on these two areas for my investigation. Okay. So that was the way to geocode and display on a map the current distribution for the stores, trying to find out uncovered areas. In the other map here, what I'm doing is simply displaying all the cities, all the municipalities in Denmark with the population. So for instance, if I want to see only bigger cities, 100,000, let's say 200. Come on. Yeah. Yes. Yes. Of course, I was moving the the wrong end. Sorry. Yes. So these are, and actually in Denmark there are 3 towns that are over 200,000 inhabitants. Okay. So in the other map, using ArcGIS, I'm showing the distribution of population into the country. And using another API, I calculated all the distances. So using the Google API for distances, I calculated all the distances from every town to the closest IKEA shop. And I rated all these points. So the lighter points are the points that are closer to a shop. The darker points are the points that are far from a shop. the darker is the point, the more is the distance. Okay. Behind there's I cannot show you because it's quite complex. It will take a long time. But behind there's an API, Google API, for calculating all the distances between every town and the shop. Then getting the closest one and then giving a rating. So again, as you can see, I have these two areas basically that are uncovered here and here. Here, there's a town called Eisbier, and down here, there's a town called Nestved. And this is where I focused for my investigation. So the towns that are, for instance, more than 50 kilometers, yes, okay. So I can show the towns that are far for more than 50, or these are kilometers. 8 kilometers, okay. So you can see that this is the area that is uncovered, and here I focused on it because here there's a town called Esbjerg that has a good amount of population. In this upper area, there's nobody basically. Okay, so that was the choice between. But I wanted to see the. I want to go further with my investigation. Close, please, and I want to see the population distribution over the country. I already showed you something, but the population distribution over the country, I am using a shape map for this kind of report. So shape map is a standard in Power BI. Basically, it's an area. It's a colored area. Okay, a shape map is usually a closed area with a color saturation range. The lighter and the parameter is low, the darker the parameter rate is high. Okay, so basically they are vectors, closed vectors, but the essential thing from the shape maps is that as they are vectors, they are represented. They are using a format called shapefile. A shapefile is a vector. It means that it has some geographic attribute, but also it has some descriptions. And I will show you how to decode, how to fetch the data from a shapefile using R. But first, let's focus on population distribution and where is it? Yes, and the combination of data of the intersection with spatial methods in SQL Server. This is a shape map. Custom visual, no, sorry, standard visual, built-in visual in Power BI. The only downside is that shape map is quite common. If you go over the internet, you can find as many shapefiles as you want for every country, for Word, no problem. But for using in Power BI, you have to convert the shapefile in a format called topo.json. We don't go further inside, but you need to convert the, not this one, and you need to use a kind of online tool called MapShaper for performing this transformation. So you have your shapefile. The shapefile is quite easy to find out, but you could also prepare your own shapefile using a GIS system, QGIS, for instance. Then you can upload into map shaper and transform the the shapefile into a topo.json that is suitable for Power BI. And this is exactly what I did. So here I have the distribution of population over Denmark, and this is a topo.json file. I cannot go that much. Okay, so here I have a custom map. I built a custom map, and this is this dklight.json file. Okay, the shape map is interactive. So if I select a single municipality, I can dig and watching the distribution of population. So you can see there's a color saturation that tells me where are the areas with the most number of people. But I went a step further, because what I want to see is how is the population distributed based on a certain area. So I'm passing a parameter to this map, and this is a nice stuff. So what I want to know is if I'm defining a buffer, I'm defining a point, and I'm defining a buffer around this point. So how is the population distribution around this point based on the buffer? And I want to make them dynamic. So these are parameters that I'm passing to my shape map. How to achieve this is not easy, and this is where SQL Server Spatial features came into action, because I'm using spatial methods in SQL Server. It means that there are some methods. I'm using two methods, intersection and don't remember the other one, special methods. And distance, of course, sure. So I'm using two methods in, come on, where is it? Yes. I'm using two methods in SQL Server because every time the buffer intersects the area, I show the area. If the area is not touched by the buffer, the area is grayed out. Let's see. So this is how it works, and then I show you. So I'm passing a parameter. So I have this commune called Odense, and this is a big number. But if I say, please show me all the towns that are 50 kilometers, because it must be written in meters. So 50 kilometers from Odense. And then apply changes. OK, so now the shape map is showing me only the polygons that are touched by this 50 kilometers buffer. OK? And this is achieved because behind there's a store procedure that is using in SQL Server that is using two simply methods in SQL Server. But there is another point in SQL Server that we need to know. So I want to actually focus on my two areas. So no, sorry, not this. I'm changing the parameter. Please show me the distribution of population. For instance, 50 kilometers is fine. apply changes. Ah, sorry, I wrote a wrong name. Yes, oh, yes. SBR. No, how's
Parameter be a slicer in Power BI?
Well, actually, I don't think so, because it's related to the store procedure, because you are passing the parameter to a store procedure in SQL Server. You are calling a store procedure. So I don't think so, actually. Oh, sorry. Come on. SBR. Ah, come on. I wrote. Oh, sorry. No, because it was written in this way. Sorry. OK, so parameter, edit parameter. Not here, actually, but here. Apply changes. OK, so this is the distribution of population. This is a SBR. And as you can see, I have here. And my list of towns is also dynamic. OK, so I made everything dynamic using what? Using a store procedure here. This one. So I'm calling a store procedure, passing two parameters. And this store procedure is applying to spatial methods in SQL Server. But there is another point, because so this is the store procedure, but how SQL Server knows that there is an intersection, there is a distance between the points, because there is another preliminary job that I got to do. So this is the call for the spatial method in SQL Server. It means that I need to have a geographic data type into my table. And this is where this amazing tool is coming to help me, because this is a very simple tool called Shape2SQL. Using this tool, I can import a shape file into SQL Server, translating the area into a geography data type in SQL Server. Amazing, really amazing, and it's free. So what I'm doing here is, for instance, I'm loading a shape file, and then I'm translating this shape file into a table. I'm uploading a shape file into a table with a geographic field. I have to tell to this tool which field is the geographic data type, and then I can import. So I'm coming from a shape file downloaded from the internet for Denmark. The shape file has been uploaded to SQL Server into this table, and this is the geomapping data. So every area, every polygon has been translated into geographic data type into SQL Server. And then I can say to the spatial method in SQL Server, if the buffer intersects this area, show it. Otherwise, don't show. I understand. It's not easy, but it's the way I want to show. Don't focus on every detail. Just take away that you can do it. Just using what it's existing. And I'm not spending any money on it. It's everything I'm doing here is for free. using free tools. So if I'm, so this is a shape map into SQL Server. You can see I have the country name, the region name, and the city name. And if I select, you can see here I have this additional tab, Spatial Result, because as it is a geographic data type, this is the output. So I imported into SQL Server the shape map for Denmark. And then I'm telling through the store procedure, I'm using the special methods, telling if the area is touched by the buffer I declared, show it. This is the idea behind. OK? And that worked also for the other data that I wanted to show. So I'm showing not only population distribution, but also income, average income, householding, age, for instance, cars availability. And for every parameter, I assigned a score. And all these infos are giving me the overview of the area that I'm investigating. Of course, if I'm changing the parameter, I can go to a different town, of course, as I showed you, and I can also select a different distance. 80 kilometers, not too many. 80 kilometers, for instance. But that's the idea behind. And this was achieved by using SQL Server and spatial support of data in SQL Server. OK, time is running, so move on. Exactly, so that was the idea. Declare a parameter, population, income, house ownership, and make a dynamic mapping with shape maps using shape map imported into SQL Server and then intercept and distance. OK. Comments? OK, are you totally, your mind is totally blown? OK, perfect. And now, now is where the fun begins, because now we are talking about R. So a lot of code behind. The third tool used in this investigation was R, because, come on, R, it's actually shipped with a huge amount of packages for performing spatial analysis. There's a lot of packages, and you can find many examples on our forums, blogs, whatever. With R, you can do everything, really everything. Of course, it's not so easy to use, but R is very powerful. So I focused on R spatial features using some packages. And what I performed with R was the road network analysis. What I mean? I have these shape files, and the shape files for Denmark for the roads from Denmark was imported into R. And then I classified and measured every segment of road into R, because there is an attribute for every segment. Every shapefile is a segment that has, not necessarily, but in this case, they had a segment description. And I'll show you. And then the other investigation with R was the shops distribution, because from these OpenStreetMap data, online data, these are free data that you can query directly from R that are showing you a lot of available geographic attributes worldwide. So what I did was to focus on 3 tags, shops of type furniture, bed, and kitchen, pulling out the data from OpenStreetMap online and showing this data on my R map. Really powerful. Let's see how works R. R. That was performed in R Studio. Come on. So R, OK. So this is R Studio. Simple, very simple example. For instance, something that before the introduction of Mapbox was not so easy to achieve in Power BI, layering. Add few layers into the same map. What I'm doing here is reading a CSV file with the distribution of the shops, of the IKEA shops in Denmark. Yes, yes?
Okay. Oh, thank you. I was just going to ask you to zoom, but thank you.
OK, OK, perfect. Then I'm importing into R a shapefile. So you can import a shapefile into R, and then some tweaking is needed. Don't ask me. I don't have the time. And then I'm adding layers and layers and layers. So let's see how it works. Import, and then this is the shapefile. But this is something that sorry, forgot to call the packages. So here there is not now. I'll show you later. OK, so OK, I'm importing some data. I imported a shapefile, and this is a shapefile into R. This is a simple shapefile. The municipality's boundary from Denmark, nothing special. Shapefile into R, imported into R. Then I want to add layers. So let's create a Google Maps. This is it's not Google. It's a different player called Stammen, but this is the satellite map for Denmark, and I want to add to this map my shapefile. OK, so 2 layers, satellite map and shapefile with the boundaries over Denmark. Third layer, the distribution of shops. Cool. 3 levels: satellite, shapefile, vectors, and the distribution of shops over Denmark that are points. OK? In R, as you can see, it's quite easy. No, it's not easy, because you need to clean up, to shape, to tweak the data. So it's not easy, but it's possible. Actually, it's possible. OK, first example. Then let's go to the road analysis I performed in R. This is very, very powerful. So let's remove all this stuff. OK. Again, I'm importing a shapefile, and I'm displaying a shape file. In this case, the shape file is from roads. So it's not boundaries, but is the distribution of roads over Denmark. OK, so this is the distribution of the roads. These are roads, OK, over Denmark. It's not the boundaries. And if I go here, this is what I get. Every road is classified. So from the segment, from the vectors, because they are vectors. Shapefile means vectors. The vector come with some geographic attributes, latitude, longitude, blah, 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 but also with some descriptions. And this is the data stored inside the shapefile. Every road has a classification. Motorway, primary road, secondary road, tertiary road. Actually, there were many other classifications I get rid of because I was not interested in private roads or whatever. But this is data that I can easily read from R, and that are stored into a shapefile. So I have 4 types of roads. But I also, let's see if I can show you. Yeah. Yeah, 1 second. Only just 1 second. OK, so 1 second. So this is the data. You see? There are 80,000 rows, secondary, primary, tertiary. So for every row, I have the classification of the row, but I also have the length of the row. And just 1 second, and I will come it later on. But I have 2 attributes: distribution, classification, and length of every segment. OK, so.
Just to clarify, that information that came from the open street. You need the road information.
No, because they are shape maps, so shape files. So they are coming from, if you download the shape file, you import into R, or open with the QGIS. If you open the shape file with QGIS, you also have the same infos. They are attributes stored into every segment has some attributes, usually. OK. Then, how to use these attributes? Yes, so I am filtering. Yes, so let's display the motorways. These are the only motorways in Denmark. OK? These are motorways. And then let's add primary roads. These are primary roads. These are secondary rows. OK, so if I filter out by the description, I can get only the data that I'm interested in, because in my investigation, I was mainly interested in 2 types of roads, motorways and primary roads. No, not this one. OK, so, and I'm giving to these roads a color, but let's, no. Yes. So I have these 4 different kind of roads, and I want to highlight by using different colors. So I'm plotting by using different colors. Still working. So I'm plotting motorways blue, primary roads dark green. OK. And OK, let's start. So I want to highlight every row, every kind of row with a different color. So yeah, what's OK. OK, so these are motorways. These are primary roads, dark green. Secondary and tertiary roads. Still working? OK. And if I add the legend, I added to the, so I can classify my roads based on the description, and I'm giving a different color based on the kind of road. But what I wanted to do was to focus mainly on the selected. OK, actually there was a legend. If I am doing it. Yes. OK, so I have a legend, road classification, and I can easily see the different sort of roads. Perfect. But I wanted to focus on the two selected areas. So I'm doing the same operation for SBR, just cropping the shapefile. So this is the road distribution and classification around my area. This is my town, SBR. And this is the road distribution over this area. I simply started from the shapefile, just cropping the shapefile for the area that I'm interested in. OK, so road distribution, and as you can see, we have only two motorways, the blue ones. We have basically two motorways and some primary roads. Same for the other area, nest bed. OK. This is where my town is in red, and this is the roads distribution over the area. Again, two motorways and some primary roads. But probably Esbjerg had a better distribution. But let's move on. OK, not this one. Move on. Because there is another nice feature I would like to show you. Because I worked on roads classification, but I also worked on roads length. Because for every segment, I know exactly how long it is. So I can decode this info, and I can show this info in an histogram in R. Yeah. So here, I'm reading ST length. I'm reading the length for every segment of my road. And I'm plotting all this data as an histogram. As you can see, the last row code is road east. I'm creating an histogram for showing this data. So, OK, what's going on? Let's start from the beginning. OK. Yes, there's a okay. There's another package coming into that. I forgot to comment. Sorry, takes some minutes to load. Yes, that was not my intention actually, but let's see. Yes, this is a dynamic package, a dynamic another way of getting the roads distribution, and this is a dynamic package called map view. So you can have some kind of interaction. Okay, but this is what I wanted to achieve. This is the road distribution based on the length of every segment. So I'm summing up the kilometers. These are kilometers on the y-axis. There are kilometers. So I know exactly how many kilometers are motorways, how many kilometers are primary roads. So I can get insights from this distribution of roads, because I focused mainly on, again, on the areas. And that was the output. So for every area, I know the road distribution, and I can compare. This one is for the first area, Esbjerg, and this is the roads length. So I have motorways and I have primary roads, and if I could easily calculate in R the total amount of kilometers. The same is working for the other area, Nestved. Okay, and this is the distribution for the other area, motorways and primary roads. And I have the total number of kilometers for every sort of road. Okay, couple of minutes, please. Please resist for a couple of minutes, because I wanted also to show you the distribution of shops. Because as I mentioned, I'm reading this one. Let's have this one. I'm reading the shop distribution from online OpenStreetMap data. And I'm plotting the shop distributions, the shops distribution for every area I'm focused. Working. Okay. No, something is not working. Let's go on the other. Let's go on this one. Okay. So I have these three kind of shops: furniture, bed, and kitchen. And this is how these shops are distributed around my area. So basically, there's no shop of these selling these items. But and I can also have the same for full country. And this data, exactly, this data is coming from OSM data. I'm querying OSM data online. Okay, so you are done, I can see. So let's have a recap. So for all these points, I made I assigned scoring, and then the last step was finding out the not this one, this one. Yes, finding out the most suitable area based on the score, and the the winner is this one, because it's darker, okay? So just summing up all the parameters and all the score for every parameter. And the winner is the darkest area. Just a recap. So, what I have used for geocoding, I've used Google APIs. I used the Power BI function. I used SQL Server, Visual Studio, basically, for the C# script. Calculating drive time, we did it in ArcGIS Visual, calculating isochrones. Shape maps, there's a Power BI Visual, native built-in visual for shape maps, but you need to convert the shape map into a TopoJSON format using map shaper. Then calculating the area intersection for every shape-file, geography data type, SQL Server geography data type, import shape map into SQL Server using shape2 SQL, and then using special methods in SQL Server. And reading data from OpenStreetMap distribution of shops, doing some image layering are spatial packages. Simple feature, spatial, blah, blah, blah. There are some. Last point, if you are interested in digging into, I'm authoring a series on this site, sqlcheck.com. There are some articles from me talking about ArcGIS, shape maps, R, also Bing Maps, how you can work with maps into Power BI. Okay? And these are my contacts. You are welcome to contact me, asking anything. You need any help, you are welcome to write or contact me anyway.